All right, guys, we are going to do the Unit 4 review right now. This is the non-calculator portion. So the directions say write each exponential statement as a logarithmic statement and each logarithmic statement as an exponential statement. Okay, so looking at number 1, it looks like we're given a log. So because we're in logarithmic form, we're going to write it as an exponential form. Okay, so use the Bay or the swoop method, whatever you've been using, but this will become 5 squared equals 25, and 5 to the second power is 25, so that logically makes sense. Over here, we're given an exponential statement because we have an exponent, so we want to write that as a log. You can still use the Bay method, or you can use the swoop method, whatever fits you best. So this 3 is the base, this 3 is the exponent, and this 27 is the answer. So I write this in log form, BAE. The base of my log will be 3. The A value is 27. And the exponent was 3. And you guys can always check it by putting it back in exponential form to see if it matches. Okay, number 3. Same thing, guys. Use the swoop or the Bay method. So this will be 2 to the negative first equals 1/2. And that statement's true. Remember that negative brings that 2 in the denominator. So that would be 1/2 to the first, which is 1/2. And then over here, we're given an exponential statement, so we need to write it as a logarithmic statement. So this would be log, let's see, 9 of 1/81 equals -2. 9 to the negative second is 1/81. Okay, good. All right, evaluate each, show your work. So when we say show your work, we want you to set these equal to x and show us your setup, okay? So this setup will be writing it in exponential form. Do you guys remember doing this? 4 to the x equals 64. And then you need to find what x power, or what power will make that equal to 64. So it is 3. Now remember, this doesn't mean you can't have a calculator on this portion. This just means that you have to use a non-graphing one. So if you guys type in 4 to the third to double check your answer, you can. Okay. All right, number 6. Set it equal to x. Okay. This would be 10 to the x equals 0.0001. Now, this 0.0001 is really a fraction. It's 1/1000. Or no, 1/10,000, right? Yeah, because 1/1000 is that. So we gotta do 1/10,000. There we go. And that gives us the same. So, because of that, remember, because this equals that, our exponent will be negative. All right, because of the fraction idea. And we have 1, 2, 3, 4 zeros, so this is -4. Okay, and you can check that. 10 to the -4th is 0.0001. Okay, all right, number 7, set that equal to x. E to the x equals e. So since these are the same, x would need to equal 1. All right, set it equal to x. 8 to the x equals 1. Anything to what power always equals 1? 0. Good job. All right, this one, there's like a couple different ways you could do this, but one way is you can use your properties of logs and move that 3 to the exponent. So this would be log 10 to the third. And 10 to the third is 10, whoops, if you're not sure, 10 to the third is 1,000, okay, you're going to have 3 zeros, right? Now you can set that equal to x and then solve. Now the base of this log, remember, if there's not a number there, it's just a known 10 to be there. So x equals 3. And again, oh, Oh my gosh, guys. That was silly. So, okay, because this is log 10 to the third, whoops, equals x, all you could have done, since you know that's a base 10, you could have said that's 10 to the x equals 10 to the third. And then notice that because these are the same bases, the exponents equal each other. So that's kind of another way you could have gone about that. I just realized that. Sorry. All right, number 10 set equal to x. So 2 to the x is 1 over 16. So x equals, it's going to be a negative because that 2 comes in the denominator, to the fourth, right? If you want to check it, 2 to the negative fourth is 1/16. Perfect. Alrighty, number 11. Describe the transformations needed to obtain the graph of g of x from its parent graph, f of x equals 2 to the x power. So here's the 2 to the x power right here, okay? So we have something extra here, here, and here. Alrighty. Now remember, whenever you have a negative out in front, that is a reflection over the x-axis. Okay. The 5 is its own separate transformation, okay? The negative means that we have a reflection of the x-axis, and then the 5 is its complete own transformation. So that is a vertical. It's going to be a stretch because 5 is greater than 1. So vertical stretch by 5. Some of you guys missed this on that activity quiz from earlier, so make sure that we identify that that's a reflection over the x-axis. This is its own transformation. 5, think of it as positive because it is positive. All right, so vertical stretch by 5. That is not a vertical shrink by -5, okay? Be careful there. This 1 tells you if you move left or right, so this is left 1. And this 9 tells you if you move up or down, so this is up 9 because it's plus. This is to the left because remember you got to do opposite up there. Okay? Alrighty. Next we're going to rewrite the expression as a single logarithm. Then evaluate your simplified logarithm and show all of your work. So when I say a single log, I should only see the word log written one time. Okay? So real quick, let's take care of these 2's that are out in front for some reason. Ugh. So log base 2 of 12 squared minus log base 2 of 6 squared. Okay. Go ahead and on your scientific calculator, that's what this is called. Sorry. 12 squared, if you don't know, whoops, is 144. So I have log base 2 of 144 minus log base 2, 6 squared, is 36. Now what happens when you're subtracting logs of the same base? You divide their insides. So I have log base 2 of 144 divided by 36, which is 4. Does that make sense? So this is the single log. That answers the first part. Then it says evaluate your simplified logarithm. So I'm going to take log base 2 of 4 and set it equal to x, and basically what I did on problems 5 through 10 up above. So 2 to the x equals 4, so x has to equal 2. 2 squared is 4. Okay? Number 13, we have one number in front of just one of the logs, so that's only going to go on that 10. So we have log of 100 plus log of 10 squared, and 10 squared is 100. Again, you can type that in your calculator if you're not sure. Okay, I'll do it right there. All right, and then now whenever you're adding logs, the insides, remember you're going to multiply them. So really we're just going to do 100 times 100. Okay, and you're going to get 10,000. All right, and that's the single log that we have. We see the word log written one time, so we know we're there. So then now I'm going to set that equal to x. Okay, this is base 10, so 10 to the x equals 10,000, and x equals 1, 2, 3, 4, because I have 4 zeros. 10 to the 4th is 10,000. Okay? All right, last part of the non-calculator portion will consist of expanding using your log properties. So we see here that it looks like this u and the v are being like multiplied by each other, right? But then we also have some exponents going on. Well, you guys want to separate these variables first before you take care of the exponents, because kind of like up here, even though we put those exponents right there, they're on their own separate log. So we need to keep the 20 with the u and the 5 with the v. So we're just going to like separate the u and the v first. Because this is multiplication, we're going to do addition. We're going to expand it by addition. This is log base 6, so make sure you guys write that 6 right there. Plus log base 6 of v to the 5th. Make sure you guys are having good notation and putting the bases where they should go, on what's inside the log where they should go, and the exponents where they should go. All right, now you guys can use the exponent property, the power property. So this is 20 log base 6 of u plus 5 log base 6 of v. And that's it. All right, number 15. Looks like we are dividing by, we're taking x and dividing it by y to the 4th. So whenever we're dividing, we're really going to subtract, right? So real quick, I just want to go over something. Remember ln means log base e. I just want to make sure we know that. It really doesn't help us or hurt us right here. I'm just making a side note there. So the base of this log is e, but you don't have to write it as log base e. You can just keep it as ln right now. Okay, so this will be the natural log of x minus the natural log of y to the 4th. Okay, and then we have that power property on the y term. So this is the natural log of x minus 4, the natural log of y. Okay, and that's it for the non-calculator.